my friends, we are going to continue with the other important information in relation with the propeller. This is the rake. Is the angle of inclination. Is the angle of inclination in between the blade and the axis of the propeller. In between the blade and the axis of the propeller. Okay, this angle of inclination of the blade with the axis of the propeller is
your rake.
The rake. Like this one.
Right.
The rake. Why the outboards they have a rake smaller than the typical inboard with a nibral propeller behind of the boat? They are more.
The angle is because it has a lot more torque, so it bites a little bit harder. It's not like a regular inboard or the two strokes in the four-stroke outboard just have a lot more power out the whole shot.
Yeah. Danny, every day we hear the people confused with cavitation and ventilation. And today we have a great example to explain the real cavitation.
Absolutely.
This is real cavitation.
This is real cavitation. That's because the bubbles are burning actually the prop from the pressure.
Correct. The bubbles explode here and erode the metal over there.
And you can see where it's eaten. 3 out of the 4 blades is getting eaten up by the cavitation.
Have the propellers of the surface drive out. If you see, those propellers are 5 blades overlap, high dar, and one propeller the blades are right side, the other propeller the blades are left side, and those are the propellers of the surface drive system. Right. Danny, other important thing, we are going to return to a boat with only one outboard. And what is the function of the trim?
Okay, the trim is like, let's say if you had a single engine and it wants to keep pulling to the right, then you would counteract it with this fin.
Okay. If I have a single engine with right side propeller, I rotate this one a little left to compensate and keep the boat straight.
Try to keep it straight.
Perfect. The propeller should be separated. On top, this is the hull, and this is the propeller. That distance should be minimum 20% of the diameter of the propeller. That distance in between the hull and the propeller. And suppose that this is the rudder. The distance in between the propeller and the rudder should be minimum 15% of the diameter of the propeller. This is a great example about that distance, Glenn. That distance should be no less than 15% of this diameter. And this one, no more than 20% of this diameter.
You mean the one blade?
Yeah, correct. Danny, now we are in front of the lower unit cutaway of the Bravo 3.
Correct.
The mechanism on top for Bravo 2 and Bravo 3 is the same.
Identical.
All right. Okay.
The shifting is up top.
On top.
See, if you notice, there's no shift rods in here, so it's just a shaft.
Correct.
Okay, so the shifting is all done up on the top side.
This is a marvelous design because you have a dual prop. One prop here and the other one over there. And both props rotate in different directions because one prop is left side and the other one is right side.
Correct.
It's dual proportion.
Dual prop. And you have more torque with a dual prop. And you have in reverse, you have just the same power in reverse as you do in forward.
Yeah.
It's incredible.
It's incredible.
This is probably one of the best drives. The only downfall of this drive is because since there's a lot of parts within each other,
correct,
they don't have a good bonding system. So Bravo 3 have a tendency of getting eaten up. This is a common problem with Bravo.
A lot of corrosion over there.
Common problem.
Oh yeah.
That's the biggest problem. That's most of the drives that I replace. It's not due because it blew up. It's due to corrosion.
It's the corrosion.